All right, in this lesson here, what we're going to do is take a look at what we need to do to develop the DrawEngine class. Now, we've already got the game loop class in place, so we've got our looping there. It's all good, but it's time to set up the visuals. Well, at least the engine for getting the visuals out to our player.
Right, we need some control.
We need to see some evil monkeys.
Yeah, we do.
We need to see our hero.
But
we need fireballs.
Yet.
Now, we're not going to see those things at the end of this lesson.
No.
Well, we may see one of them. It may not be the real hero or real evil monkey.
We'll see something drawn on the screen.
But we'll see something drawn on the screen. We at least get an engine in place that is capable of being instructed where to draw something and what to draw,
That's
and
right.
it'll handle it for us. So that's the whole idea of this lesson, and get that in place because it's very important.
Oh,
obviously.
yeah.
So first thing we're going to do before we jump into code is take a look at the big picture. Because now, starting with this lesson, things are going to become more and more complicated.
Yep.
And with that, we really need to talk about what the big picture is, what type of functionality are we looking at achieving by the time we're done with our class, what functions do we want to create, what kind of data do we need to store, and once we understand all that in plain English,
yeah,
then we can move into the coding part and start breaking it down that way.
Right, because it's pretty easy to get, like, totally lost in the code.
If you sit down and you start designing a game, I mean, it's a good idea to kind of
have a concept.
Get your concept,
yep.
and then come up with a design spec, and then of course you'll go back and change that. I mean,
but it's a lot easier and more convenient to change it in the design stage than it is to change it after you've implemented half the game.
Exactly. I mean, you just don't want to sit down and start coding.
I'm
going to code the next Unreal Tournament.
Bad idea.
Yeah, bad idea. Start on paper first. So here we are on paper, well, notepad, but close enough. And let's start talking, Joel, about what it is that we need to do.
All right. Well, with our DrawEngine, we need to have a method to create sprites. Because if you think about, as we talked about before, what is a sprite? A sprite is a 2D image, right?
Right.
In our case, it's going to be an ASCII character.
Yep.
Well, we want to be able to draw these on the screen. So we want to create a sprite repository, as we have up here. Well, our repository is like a bucket.
Yep.
Right? And inside the bucket, we can place our sprites. A container.
It's a container, and we put things in that container as we need to.
That's right.
And we're going to say we're going to create a sprite by saying, here's a picture, put it in the bucket, and we want a number associated with it so we can retrieve it from the bucket
whenever we need to.
So we can say, like, number 0 is our hero.
Yep. And 1 is our evil monkey.
Evil monkey.
And 2 is our fireball.
Fireball. So then later on we can easily say we want to draw number 2 and we're going to be drawing a fireball.
That's
or
right.
if we want to draw 0, we're going to be drawing our character, our
That's
hero.
right.
Okay? So it's just a container. That's all it is.
So from there we have to have a function of some sort that deletes a sprite. Now in our case this is only conceptual.
And let me go back to one thing real quick. Now with the create sprite repository, creating a sprite, that's actually creating that reference, the index and the character.
That's right.
Okay, that's an important thing to make sure they understand as you go into delete a sprite, where we now have the ability to basically pull it back out of the bucket and throw it away.
Right. In our case, since we're just dealing with ASCII characters, we're not actually going to remove the delete. A sprite is not going to have any functionality. It's just going to be there conceptually.
Yeah, if we decide to port this later on,
right,
which we will be,
right,
we'll be able to use this functionality, and it'll just be already built into the class.
That's right.
And we won't have to worry about adding it in.
Which
well,
is
the
just
concept
good,
of it.
it's just good programming.
Yep. So from there we have how to draw the sprite onto the screen.
Right. The create sprite. This does not. I'm just saying this again, representing the student union out there. All because we said create sprite doesn't mean we created a sprite on the screen.
We created a sprite in memory.
We created a sprite in memory.
Just because we created in memory doesn't mean we can see it.
That's right. So now by saying to draw the sprite on the screen, we can now simply say, look, let's look over in that container. And let's say number 3.
Yep.
We're going to draw him, and we can send that out along with some coordinates.
Right, X and Y.
X and Y. And then it'll then be drawn on the screen. And that's the draw sprites functionality. That's its responsibility.
Yep. And then from there we have erase sprites from the screen, because at the moment we're dealing with ASCII characters, right?
Yep.
And we need some way, if we move our sprite, we need to have some way of erasing it from the screen, because it doesn't just, you don't move an ASCII character.
Otherwise you're just going to leave a copy of him. It's going to look like a copy of himself behind. So it's suddenly going to be hero, 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 all these heroes all the way across as you run from left to right. And that's just not going to look
Just imagine holding down the A key.
Yeah.
That's exactly
That's
what it'll
look like.
Just keep printing.
And from there, we have the ability to move the cursor to a location on the screen. If you remember, if you just do a cout statement, it's going to print out. If you do another cout statement, it's going to append to the end of that.
Yeah, well, it's going to print out from left to right, starting at wherever the cursor's at.
Yep.
Okay, so let's say you're starting out with a new app, up in the upper left-hand corner.
Yep.
And then, like you just said, it's going to append to the very end of it, and to the very end, until you give an inline.
Right.
But that's not really going to work for
not
making
gonna
a cool-looking game.
Because there's no way to go back to 0, 0.
Right.
So what we need to do is have the ability to move the cursor back to wherever we want.
To anywhere we want. Yep. Exactly.
At any time we want.
At any time, absolutely.
So from there we have the ability to hide the cursor. And as everyone remembers, in a nice DOS-type window, you have the little blinking cursor thingy.
Called the...
Cursor.
Carrot.
The carrot, yeah.
And the carrot can be quite annoying when you're supposed to be playing this ultra-cool game and you got flash, flash, flash. Okay.
Yeah, exactly.
Yeah. So we need to hide that.
Right. And from there, what kind of data do we have? As we were talking about before, we need our sprite character array, which is our sprite repository.
Which
our
is our bucket.
container.
Yep. And from there, we have our screen width and screen height, which is just going to hold, our screen width and screen height.
Yeah, in this case, it would be like 30 by 20.
Right. But this is not really necessarily important right now. This is going to be coming into play when we get into the level, when we start printing out our level, drawing our level.
Right.
Right now, this is a conceptual thing that we need to have in place.
But it's gonna come into play real soon.
Yes, it is.
Now this is just an overview, if you will, big picture. Now on the right-hand side, you'll notice that what Joel has done is he's broke it down into all of the function names. So these will be the names that we're using. So when you see create sprite, there's no reason to panic. We've talked about what it does. And delete sprite, same thing. Draw sprite, erase sprite, go to XY. You guys see some fancy word like that. No big deal. We're just telling to put the cursor in a specific place. Cursor visibility, and then we've got, of course, our variable names as well.
Yep.
So now that we've got a big picture, let's go ahead and jump back into our project.
Woohoo.
And let's start out by creating a header file.
All right, so let's go over to header files, go to add, and say add new item. What do we want this to be?
A header file.
DrawEngine.
DrawEngine.
.h.
.h.
There you go.
So we have our DrawEngine.h file. Now, what do we want inside of this guy?
Well, first of all,
there's a rule.
There's a rule.
What's this rule, student?
That's a pretty cool can. Well, we got to make sure that it's, if it's not defined.
Right, so we need to put that in here.
Because we don't want to define it over and over because, we've already seen in past lessons we can run into problems.
Yeah, we can run into some problems.
That's right. So
not defined.
The name doesn't matter again, but you have to be consistent in your header file.
Consistency is important. So let's just end off that preprocessor
Look
definition.
at that. He followed the rule nicely, Dan.
Yeah, I'm impressed.
I am, too.
Thanks a lot.
You're
All
welcome.
right. So now let's define our class, our draw engine.
And inside of this, we can actually just define all the functions that we have.
That's right. Why don't we just define all of them first?
Yeah.
The first thing, we're going to define our constructor, right?
Yes.
Our constructor is going to have the same name as our class. And inside of here, we're going to pass it. Remember, we talked about the screen width and screen height. So we want to pass it, the screen width and screen height, to the constructor. And we'll give it a default value of 30 and 20. So y size equals 20, and just end that off.
Yep.
We're also going to give it a destructor, which it will come in handy in a little bit.
Well, what we'll do inside of the destructor is turn the cursor visibility back on.
Right.
And inside the constructor, we'll turn the cursor visibility off.
Then from there, let's go ahead and create our sprite. Now remember, create sprite is going to put a sprite image into the bucket, and it's going to assign an index to that, right? So we're going to return the index as well.
That was assigned to
that sprite. We're also going to, however, pass the index to the create sprite function.
Yeah, because under the hood inside of this version, whatever index we pass into it is actually going to be passed out unless an error occurs.
Then we'll get something
and then we'll
different.
pass out a negative number because a sprite in the game won't have a negative
right,
index.
so basically you can check if create sprite, and we pass it the index 2, returns the value 2, then it worked.
Yeah, you're all set.
Right. So from there, we also need our delete sprite function. So delete sprite, and we're just going to pass it int index. From there, we also need our erase sprite function. Erase sprite. Nice.
And we're just going to pass it the coordinates
position
X and Y.
Position Y.
Because what we're going to do is just draw a space character.
That's right. We don't need to tell them which one to draw.
Yeah, because a space will effectively erase it.
Yep. And now we have our draw sprite, which has two things, actually three things. The index, which is which one we're going to be drawing.
Like the hero, the evil monkey, the fireball.
And then we're just going to pass it the position X
and
the position Y.
At.
Yep. And we need a little bit of local variables here inside our protected variables. Our screen width and our screen height. Simple enough. Also, we're going to need 2 private functions. Which 2 ones are these? Do you remember?
Well, we need the ability to move the cursor, which was go to XY.
So go to XY. We're going to pass it where to go. So int X and int Y.
And we also need the ability to turn on or off the visibility of the cursor.
So cursor visibility. I'm going to capitalize B.
And we're going to pass it a bool.
True or false?
Which is true or false. If it's false, it'll be hidden. If it's true, no. I had that backwards. No, I had that right. Joel, help me.
Cursor visibility
set to true means you see it.
If cursor visibility is set to false, you won't see it.
Yeah, that's what I meant.
Yeah. Now we know. And I do remember the semicolon there, and it's important.
Not that Joel is
I've never forgotten that. In the source files, we're just going to right-click. Since now we have the header defined, we can go ahead and create our source file.
We're going to start implementing the code, so to speak, the actual meat of each function.
CPP, there we go. And the first thing we can do is just say to include.
To include our DrawEngine.
Because this file needs to know the template. It needs to understand what class is being made and what functions are associated with that class.
Exactly.
Right. Yep. So the first thing, we'll just create our constructor. So DrawEngine, and of course we have our int x size and our int y size. And inside of here, all we need to do is set the screen width equal to x size and the screen height equal to the y size.
Yeah, because a constructor is a place where you'll take care of assigning any variables you need in the class.
That's right.
Any pre-functionality that you need to make.
Right. And even though we haven't set up
we'll just say set cursor visibility.
Yeah, because we have mentioned already in the concept that in the constructor we're going to want to go ahead and hide our cursor.
Yeah, so when we get to implementing that, we'll come back
and put it there.
Right. Next, we'll just go ahead and implement the destructor as well. And all this is doing is
set we see our cursor
visibility to true. I kind of typed it wrong here. To false, my bad.
That's what happened to me earlier, wasn't it?
Yeah. Okay. Now we have our draw. Now we're going to do the create sprite, because that one's important. We need to create our sprite before we can draw it. So, create sprite. And we need our int index and our character C. So inside of here, what do we need to do? Well, the first thing, all we need to do is say, remember, what is the array that we have inside? Sprite image. But we forgot to create that, didn't we?
Yeah, we did.
So let's go back to our header. And remember, we have our variables here. Let me just switch back over to Notepad for just a second. You notice we have the sprite character array. And we define the name as sprite image 16, which means we can hold only 16.
16, right? Yep.
Of course, we can extend that to however many we want, but...
Right. And now at this point, hopefully our viewers remember the lesson on arrays from way back, and they can see the association now between this index number and the actual character, because the character is being stored in that specific index number of the array.
So this is how difficult this function is going to be after we define
we actually define it.
Right.
Array,
so sprite image 16. If we save this, come back into the DrawEngine, all we need to do is say sprite image index equals C. Yeah. Wasn't that hard?
Wow.
Wow.
Tough.
And of course, we're going to return index. But we also need to do another thing. What if, since it's from 0 to 16 right now, right?
Yeah.
What if it's outside of that?
Ooh, that's
that would be bad, right?
Yeah, because we're going to be walking off our area of memory.
We're into someone else's memory.
Yeah, and that's bad.
That's real bad.
Never touch someone else's memory.
That's right.
No.
That's really bad. So what we need to do is say if index is greater than or equal to 0. We don't want it to be negative numbers.
Right.
And index is less than 16. Because remember, it's 0 base, so it's 0 to 15.
Right.
And if it is, then we're going to create this and return. Otherwise, we're going to return -1, which means error.
Something bad.
Something bad happened. So now that we have it created, let's implement our draw sprite function. So let's go into here and say this returns void, and inside of DrawEngine, we're just going to say draw sprite. Dink. And inside of here, index and position x and position y, and just inside of here. Now, what do we need to do? Let's see.
Well,
go to
for draw,
let's do this because we actually don't have this function yet. Let's do another just outline.
Okay.
What we need to do. We need to first off
we'll need to put the cursor at
position.
just in English. We need to put the cursor at some location on our screen.
Right. Go to the correct location.
Yeah, and then we need to actually physically draw the image.
Do you want to just comment that?
Yeah, just comment that.
Draw the
image.
So, what do we need to go to the correct location?
Well,
go to XY.
Go to XY.
Right. So let's define that guy. Void draw engine, go to XY, and this has int x and int y.
Now, this is where things,
Get a
again,
little bit
for
interesting.
beginners are going to become a little interesting, perhaps even a little bit confusing.
But it's really not that hard.
But it's not that hard. The first thing to understand is the fact that when you're programming with Windows like this, we've got libraries out there that have tons and tons and tons and tons and tons of functionality just
That's right.
waiting on us to call
grab
upon
them.
it. In other words, there's no reason to have to reinvent the wheel all the time
Yeah.
in programming. Right?
That's right.
So what Joel's about to do is make use of this functionality that's sitting out there for us.
He's going to go to API land.
Woohoo,
API
API
land.
I like it. So, first thing we're going to need to do is create a handle to our output handle. Now, what is a handle?
A
handle
handle-
is... Okay,
It's
you
just
go
a
ahead.
data type for starters, so go ahead.
A handle in Windows is always an ID, which associates
A
with
unique ID.
a unique ID that associates with something inside the system.
Right.
So a window inside of Windows actually has a handle which
Right.
says I'm handle number 119.265.68
And
Or
proud
whatever.
of it.
or whatever. And in this case, if we want to do standard output or input, that also will have
An ID as
standard.
well, unique
Right,
ID.
so this output handle is basically to see out, the handle to see out, if you will. Sort of kind of that way. So what we need to do is say set console cursor. This is a API call. Set console cursor position. Now check it out. It knows that this exists. And look at the two things it needs. It needs the H console output, which we
is a
will
handle.
have, right? And a core DW cursor position, which is an X and Y value.
Right.
So, first thing, we'll just pass it output handle. But you'll notice that we haven't initialized output handle yet, have
No,
we?
we haven't.
So what we need to do is come up here and actually get that handle to our output.
Which is another API call that you're going to use, which basically asks Windows, please give me this handle.
Right, so that I can use
So
it,
I can use
or a reference, or whatever. So inside of here, we can say get STD handle. And look, get STD handle, get standard handle, is ask for which handle we want to get. And what we want is to get the STD output.
Now, don't be scared if you're saying, well, how does Joel know all this information?
Yeah, well, you can go in what is called MSDN, which is the developer network.
Which
It
we
has-
actually saw in the previous lesson,
Yeah.
did we not?
And we're going to see it again.
Yes,
And again.
if you
And
hold
again.
your mouse
And again.
over, just have the cursor here at get STD handle, we'll press F1, and you'll notice over here in the index we have get STD handle selected. If we click on that guy, check it out. Platform SDK. The get STD handle function retrieves a handle for the standard input, standard output, or standard error device. Well, we know we want the standard output, right? So we come down here and we say, ooh, STD output handle. That's what we want. So we say, all right, we'll pass it that, and it's going to return to us the handle. So if we come back to DrawEngine.cpp, that's set up. Now we can come down to set console cursor position, and we pass it output handle. Now remember, we also need a chord. It's a chord data type. So we're going to say CORD position.
And then stop right there. Just use the CORD.
Yeah.
Think about it as if you're a beginner right now.
Mhm.
Say, okay, well, I can type out CORD like it just told me to.
Right.
Now let's find more information on it.
So we press F1,
Okay.
come over to here.
Okay.
Ooh, the chord structure defines the coordinates of a character
A struct,
file.
which
It's
we've
a
talked
struct.
about before.
Yes.
Right. All it holds is a short X and short Y.
And it looks very similar to a point.
Yes,
As
very, very
defined
similar.
previously in a VTM.
Yeah.
Oh,
Yeah.
yeah.
Ah.
So
How do
if
you
we
know?
come over to here, check this out. If we say position dot, we can access that
Wow.
inside.
And in this case,
item.
it's capital X.
capital
Yeah.
X
But that's just because of the way that Windows defined it. So
Yep. equals X,
The X that's being passed in to this
and then
function.
position Y equals Y.
So now we have a chord, if you will.
That's right. And let's check this out for a second. Think all we need to pass is chord DW cursor position.
So what handle are you? What unique window are you looking at setting the cursor to this
position.
position? And
Right.
then what position do we want to do?
So we just pass POS.
POS, there
And
you
we're
go.
done. And with a semicolon. So that's all there is to it. Now, let's try to compile this just for a second here, because you'll notice something interesting. Dink error handle undeclared identifier.
Oh, no.
Ooh.
That makes me think that, well, somewhere along the way we've
It's
got
not
to
been
tell
defined.
this that it needs to
Be defined.
define it. Yes. Where does it get this from?
Right.
We need to make it aware. That's the word I was looking for.
Yeah.
I was digging for a specific word.
And it's going to
So
be an include
This
statement.
is probably an include thing. But before you type out what... Okay. Before you type that out,
Good point.
let's show them, how do you know what to include?
Well, let's say get STD handle, all right? Or let's choose set console cursor position, so we haven't looked at that yet.
Yeah, that's cool.
We press F1, click over here, and check it out. It does its thing.
Blah,
we
blah,
come
blah,
down,
blah, blah, blah.
check it out.
Header.
Header. declare it in wincon.h, include windows.h.
So it's telling us to include.
Yeah.
Windows.h.
And by including this, of course, then our application is going to be aware of, well, what it is.
So if we come in here, we're going to use windows.h.
And as a consequence of including that, we also know what a handle is.
We know what a handle
We'll
is.
know what a coord is.
We know what a get STD handle
Yep.
is.
All that.
All that stuff.
It's all defined in Windows.
So if
and,
we try
and
to-
if you think that's everything that's included in Windows.h,
No.
man,
Oh,
there's a lot of stuff.
In fact, just to freak people out just a little bit, we can right-click on this guy
Uh-oh.
and open this, and as you can see, there's a lot of stuff in here.
And it's some interesting nighttime reading.
Oh, yeah. And look at all the
See,
includes.
it includes
Whoa.
all of these as well. Like wincon.h is where what we had a second ago was included. So if we open this up, check out this.
Oh, wow. Now it's
All of this in here is included. So not to freak you out, but I just want you to understand that a header file is just like our header files. We're just including someone else's.
there you go.
So with that set up, it's compiling very nicely now. Now what do we need to do? Well, we need to go to the correct location. We now have the function necessary to do this.
So we can tell them.
So we can say go to XY, position X, and position Y.
Wow.
That was hard.
That was very hard.
So now with that set, how do we draw the image? We can use cout.
Okay.
So cout, because we're now at the correct location,
Mhm.
sprite image, grab from our bucket the right index, dink, the right image. Simple
And
as that.
That is a draw sprite function.
Now, just watching Joel type in that function there just kind of made me think about something that's worth pointing out here. When programming, it is a good idea to always leave comments behind.
It is.
And we just had a couple of really good comments in there explaining in English what it was that we were doing. And generally, you're not going to want to remove those. Especially
No.
if you develop your application by first going through your functions and just putting in base comments so that you can then go back and continue adding functionality in later.
That's right.
You want to leave that stuff in case, A, you come back to it a month later and you
Go,
think,
oh, what'd that do?
what was I doing here? Then you
Yeah.
spend an entire day trying to figure out what your logic was.
Yeah.
Or if you get fired and Dan comes in and sits down and goes, what was he thinking? And then
Right.
Dan's got to spend a day figuring out what you were doing.
That's right.
So these comments are really important. Now, we have not been doing it a lot. Of course, I'll start kind of pushing Joel just a little bit as our applications become more and more complex.
Complicated.
But yeah, do keep in mind, right now we are keeping things relatively simple, but they will become a little bit more involved later.
Yes.
And comments will become important. So as a beginner out there, please try to remember, throw these comments in there as much as possible.
All right, so with that, let's try to compile this, and you'll notice another little problem. Cout, undeclared identifier.
Oh, but we've seen this one
We've seen
tons
this
of
one
times.
before.
The good old
IOStream.
Yeah.
And then using namespace.
SDD.
How's that?
It should be much better.
Ding, it's happy.
Hey.
So with that, we actually have a working thing going on here.
But now we need to test this out.
Yeah.
Does it
So
work?
Let's just switch back over to our solution here. Go back to our game.cpp, and let's put this guy in here. But where could we define it? We could define the DrawEngine right here, an instance
That
of
would be as a local variable inside
Right.
of the function run.
But then that means that our timer update function couldn't access it.
Yep.
This guy couldn't access it, so we don't want to do that, right? What we're going to do is go to the game.h and put it as a private variable.
Yep.
Which makes sense, so that every function inside of this class can access it.
That's just for convenience sake.
Yeah. So we can say DrawEngine, draw.
But of course, we need to make sure that game.h is aware of
That's right.
DrawEngine.
So what we need to do is make sure that this right here is we have include DrawEngine.h right here.
Right.
So DrawEngine.h is right there.
I didn't realize it was already there.
Well,
I'm fast,
Yeah, you are. That was the fastest typing I've ever seen.
Actually, maybe it was just a drop frame in the video.
Yeah,
Oh, yeah.
you probably missed that.
Yeah.
Yeah. But definitely make sure you put that in if Joel was just so fast and you didn't happen to see him doing it.
Yeah.
Or
I'm
maybe
getting,
we accidentally left it there from in the
Oh,
past.
shh, no.
No, that
No,
can't
This
be.
is the
Not
first
happening.
time we've ever done this video.
Exactly.
So if we come over to game.cpp file, we now have our draw area defined, right? So what can we do? Come in here, draw area dot. Let's create a sprite at index 0. And let's make it our evil monkey.
Evil monkey.
Hey, it's the evil monkey.
And then we'll draw him at draw sprite. Let's say we want to draw 0 because that's our evil monkey. We'll draw him at 5.5. All right?
So in other words, what we should see is when we get our little console up, 5 units over, 5 units down, X representing left to right, and Y is from
Up and
top to
down.
bottom. And 5 over and 5 down.
Evil monkey. is coming on the screen.
And since characters are taller than they are wider, it's going to be further down.
Yep.
And there you go. Look at that.
Look at that. There is.
Oh, look at that annoying blinking cursor.
It's a blinking beacon.
This comes back to another function that we were going to implement, which was
Yeah.
Cursor
hiding.
visibility.
But we do have an evil monkey.
Yes, we do.
We do.
And look how evil it is.
It's evil.
It's scary.
And the frame rate is still 30 frames, I
Yeah,
saw.
Yep.
very nice. Yeah, that was quick, but yeah.
So let's come back over to our DrawEngine.cpp and implement the other functions that we need to do. So first one, cursor visibility. So let's come in here and do our cursor visibility with not bool.
Vool. It's fuzzy logic.
Fuzzy logic.
And we're going to do
scary.
another API land trip.
That's right. It's going to be exciting. First, we need our handle to our output.
Here we go again.
Just like we did before, because we're changing the output.
That's right.
So we need a handle to it so that we know what to change. From there, let's just go ahead and put in the output handle, get
It's
Get
the same thing
STD
as before.
handle.
You can copy and paste if you wanted to.
I like typing.
I know you do.
You'll need to add a equalities sign in there.
Shh.
He-
Dan. I was going to laugh at him.
Oh, I'm sorry.
I
I'm
like
sorry.
putting the equal sign afterwards. All right. From there, what we can do is set the console cursor info. This is another API call that we can do. So set console cursor info. Let's see what it needs. It needs the console output,
Obviously.
the handle, and it also needs this thing that's a constant console cursor info, which is another structure. And it's a pointer to it called LP console cursor info.
Oh, representing the student union here.
You're scared.
My head just popped.
So what
Bink.
this means is we need to declare instance of console cursor info.
But that looks so scary, Joel. Is it going to be as bad as it looks?
No, check this out. We can say console underscore cursor underscore info.
But what
right?
the heck is it, Joel?
No kidding.
All right.
Joel's like, I don't know.
I'm like, why don't I use F1 and show you guys?
Oh, yeah,
Such
F1.
a handy feature. There it is.
So let's see. The console cursor info structure contains information about the console cursor. Never saw that one coming. DW size. All right. And we have be visible, which is what we want. Be visible is going to
yeah.
control whether the cursor is
So that's
visible
going
or
to be
not.
the true or the false value that
Right.
we passed in.
Now, the DW size is a percentage of the character cell that is filled by the cursor. Blah, 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 blah.
Oh, wow. So we could play with that if we wanted to, but
No.
we don't want to.
No.
No.
Exactly.
So what we're going to do is just go CCI info dot be visible equals visibility.
Whatever was sent into the function.
Okay.
Visibility.
You can do it.
Thank you.
You can do it.
I missed an eye.
You can do it.
Okay.
You can do it.
Oh,
I know.
yeah.
I told you. That's good. That's good.
All right. From here, we're just going to pass output handle and a pointer to it, which means we're going to need dink the ampersand CCI info. End that off. Dink, dink. Now let's compile it. It's happened.
Hey.
But now we need to use this, don't we?
Yeah, because we were going to
Hey.
use it in our constructor and in our destructor.
Exactly.
Right.
And we even
Set-
left comments behind there.
Yep.
They are.
Set cursor visibility to false. So let's go into here and say cursor visibility, and then false. And then copy this guy and put him down here as true.
Just so that we make sure we turn the old cursor back on.
Yeah.
So if
See
we
it
run
again.
this, we won't have the blinking.
It'll be
going on.
just an
Dink.
evil monkey.
Hey.
And wait a minute.
Oh.
Here's the thing that we need to do, which I purposely left out so that you guys could see it in a second.
Ah.
What we want to do here is, if you come over to here, you'll notice it says something about percentage of the character cell that's filled by the cursor, blah, 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 ranging from all that kind of stuff. What I'm going to do
There's nothing that deals with what you just saw.
is nothing to do with what you just saw. I'm going to set this structure, DW size,
The item inside that structure.
just to the size of the console cursor info. Actually, you know what I'm going to do? I'm going to show you guys the set console cursor info, just so you guys can see what's inside of it.
Okay.
So let's come over to here and check it out. Dinga dinga. The DW size member of the console cursor infrastructure specifies the percentage of a character cell that is filled by the cursor. If this member is less than 1 or greater than 100, set console cursor fails. So why don't we just put in the value 1?
Okay, because it failed before.
Yeah, I don't know what I was
because
doing
it
here.
was a junk value.
Right, it was a junk value. We don't know what was in it.
And it just happened in this case not to be between 0 and 100.
That's right. So if we compile this guy and run him,
Evil monkey, no flashing cursor.
evil monkey, no flashing cursor. Isn't that great?
I like that.
Yeah.
Yeah. And then if you hit a button, of course.
Dink, 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 dink,
And now
dink,
hit
dink,
Q.
dink, 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 But looky,
Our
our cursor is back.
Yeah.
Isn't that great?
Hey. All right.
All right, so that's our cursor visibility function. Let's see. Did we forget anything?
Well, we have the erase function that we aren't going to actually implement, but since we're talking about it, we might as well put it inside
Just
the
get
code
it
as
set
an
up.
empty function.
Yeah.
Right. Our delete sprite, you mean?
Yeah, delete sprite.
Not, you're saying erase sprite. We do need to implement that.
I'm getting confused.
Uh-oh. So let's implement our erase
Wait,
sprite
stop.
first.
Let's do this.
Okay.
Because if we're getting confused, then our viewer's no longer watching this. He's done going to the bathroom again.
Oh,
Bring
no.
up Notepad again.
Okay. Go down.
So let's
Bring
get
up
back to the
Notepad.
big
Okay,
picture.
so
Look,
we created the repository.
Let's put a star here.
There you go. That's what I want to see.
We drew it.
We draw this right.
We can move on the cursor.
We can move the cursor.
And we can hide the cursor.
We can hide the cursor.
And we have the sprite
We have
character array.
these. We have this, and we have this guy.
Okay, so we have two things left.
We need to
Delete and
erase.
Like,
Like
but again, the big picture helps to keep
It
everything
does,
clear.
It does.
So let's come up to here, and just for buzz, we'll put it in the right order. We'll delete the sprite first. So void, delete, draw
Yeah,
engine,
that's a good thing.
delete sprite.
Do-do-do.
It's so much fun being the guy that types. I
Which
get all the
sprite you
crap.
want to delete out of
Yep.
the array.
In our case, though, as we were saying before, we don't really
We don't
need to
need to
implement
do it.
this. And
But the framework's
this
there.
implementation, we don't need it, right?
Yep.
But this is conceptual, so we want to have that there. The next one is going to be our erase sprite. So right here, what we're going to do is say void draw engine erase sprite
And
in
it's gonna
position
look-
X and position Y.
So in other
Very
words,
much like
where
draw.
at do we want to put a space? Since we're just dealing with ASCII characters right
Yep.
now. So now we have a position X and a Y to basically instruct the cursor to go to,
Right, so
and then we can see out of space.
this is going to be hard.
Oh, wait. Oh, okay.
Man, that was tough.
Was that tough?
Yeah, well, no.
No inline at the end of that?
No inline.
Yeah,
We-
of course not.
Well, we could,
Yeah, we could.
but, there's really not a point
No,
because
there's
when we
no
call
point
it
at
again,
all.
we're just going to go
to another
X,
specific
Y,
point, and exactly.
Yeah. So let's go back to our notepad here. We got this guy, and we got this guy. We're done.
Yeah. Now,
Now, we want to show it off.
let's see how this baby works.
Yeah.
Let's take it for a test spin.
Test bin. So let's go back to our game. You know what? I'm going to exit this because it's bothering me. And let's come back over to here. And now I want to define a few interesting things. I want to have my cursor, my this evil monkey, kind of go from left to right and kind of just loop back and forth like that. Not back and
Okay.
forth, just loop, loop,
Well,
loop.
we could use that to show off the frame rate thing,
Yes,
right?
we can.
How
So-
fast can he run back and forth?
That's right.
Evil
so let's-
monkeys can run very fast.
Oh, yeah. If
Yes.
we don't take in the control for game speed,
That's right.
They go out of control.
he's going to be unbelievably fast.
So let's take out draw sprite from there, and for now, I want to put him right here. So every time I press a character, he's going to move forward one space.
Okay.
But we need to have this guy say position X. We haven't defined position X yet, have we?
Okay.
So what we need to do is save this, and let's go back to our game.h, and inside of here, let's define a variable called int position X.
And you're doing this just as a temporary variable.
Temporal, just to show off.
So that all of our functions can have access to it.
All right.
So if we come back to game.cpp, let's make sure we define position X and set it to 0 first.
Okay.
Initialize it. Now we're going to say, all right, we've put it at position 0. Let's increment it. So now it's going to move to the next position, right?
Which would be to the right of the screen.
That's right.
Okay.
So let's compile this and try to run it. Dink. So nothing's going to be showing up yet because we need to press a button.
Okay.
So let's press space. Dink, 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 dink.
There's an evil monkey. Hey,
Our
he's
evil monkey.
leaving that trail behind that we were talking
Yes.
about earlier.
And you notice
as well.
that here's what you pressed is continually being reprinted.
Right.
It's being printed where
Right
we
Here's
after.
the next thing.
Yeah. So what we need to do, let's press escape. And let's get rid of this. Let's just comment this out for a second.
Okay.
And now we need to erase that sprite, don't we?
Yeah, because we don't want to leave that trail of evil
The
monkeys
old
behind
one.
us.
When we moved over, we want to get rid of our old self.
Yep.
Right. So let's go draw array.erase sprite and erase it at its current position. So this and 5. Then move
move
it to the next
forward.
position
And redraw.
and then redraw it. Right?
Excellent, yeah.
So let's compile him and link. Run him. Dink, ding, 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 ding.
Ooh, you have created a game of can
Something.
you get from left to right?
Yeah. Now let's take advantage of not having to have the user press a key. It just directly moves forward
so that
over
we
time.
can see exactly what rate our game's running.
That's right. So if we press Q, you notice it's still 29.425
Not for
frames
long,
a second.
baby.
Not for long.
Well, it still will be, but the way that we're drawing it, because we're not going to be inside of the timer update,
That's right.
it's going to go wicked fast.
That's true.
So
Wicked fast.
if we put this guy right inside of here, what's happening when we're inside of this loop is we're waiting for a person to press the key. So nothing's going to happen, right? We're going to say timer update, then we're going to draw it. So there's no limit as to the speed right now.
Okay.
It's just going to go as fast as it possibly can. Here's what we're going to get. It's going to look really strange, so don't freak out.
That's a lot of evil monkeys.
Nice sound effects, Joel.
Hey,
that
thank you.
is an army.
That's an army of evil monkeys. Pretty freaky. Now here's the problem that we have. Position X. We have 80 characters that we can print across the screen. But I'm going position X, +1, +1. When it gets to 80, it continues going up.
Oh, it goes to 81, 82, 83.
It can go all the way up to some massive numbers right now. So what we need to do is have it, when it gets to 80, go back to 0.
Okay.
Or when it gets to 79, go back to 0. Whatever.
No, it would be 80.
Yeah, it would be 80.
You want it to be 0 again.
Right.
And Joel is going to do something very special.
I'm going to do position X +1, and then I'm going to say modulus 80. So basically what this is doing is that when it gets to 79, it's going to +1. And when it says modulus 80, what's 80 divided by 80? What's the remainder?
Nothing.
It's
a
0.
Big old 0.
It would be equal to 0.
Starting back
where
over.
starting back over again. So what it's going to do is loop all the way
so
around.
That's all it is. It's just the division and the remainder. That's
Yeah.
what you're dealing with when you're dealing with modular.
Right, you're
Go
saying...
ahead, Dan.
I was just going to do a physical example with 4 numbers.
Okay.
So if we have 0, 1, 2, 3.
Yep.
If we were modulating 4,
Right.
we'd say 4, which would actually be 0.
Right.
5 would be 1. 6 would be 2. 7 would be 3.
Right, and that means 6 modulus 4 is 2.
Yep.
Right.
Representing the student union, I know that some of the students out there are very confused, but my suggestion is take a piece of paper and a pen and draw it out with just the 4 numbers. And I think that'll make it a lot easier to see what's going on, because this could be kind of difficult to visualize if you're not a mathematical person.
Yeah, actually, a really easy way to do that would be just write out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every 4 numbers, draw a line. So in between 4 and 5, draw a line. In between 7 and 8, draw a line. Then underneath it, write 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and you'll actually see the lineup if you write them one underneath each other.
Right.
So, with that out of the way, let's try to run this so you can see what's going on.
Oh, just getting my sound effect ready.
Whoa.
That's really, really fast.
That is fast.
I can hardly see an evil monkey on that screen.
And actually, the people may not see anything.
Good point. To them, it looks slow.
Yeah.
It was catching it just right.
So let's exit that, and let's start capping this guy. So, I did not mean it that way. So what we can do is cut that guy out right there, and go over to timer update. And remember, if we are not running at the correct speed, we haven't waited long enough, it's going to directly return.
Yep.
So if we get down into here, this is where we want to now do an update.
Yeah, because we're at the correct time when we can do an update.
Yep. So if we do it this way, we should get our nice limitedness. Fancy.
And a monkey.
Oh, look at that.
Hey.
And the monkey goes to the end,
He
loops
comes
back.
Now you can
Goes to
go
the end,
ahead
loops
and
back.
change your game speed number.
Yes, I can. If I come over to here, and let's say game speed, I'm just going to say maybe 500.
That's going to be quite a game.
Look at that. It's very, very
That's so
slow.
fast that I
Yeah.
might be able to play it. I might be able to actually defeat the evil monkeys.
Buzz might actually be able to play the game we're making.
Rock on.
So as you can see, by controlling game speed, now we effectively control the speed of our updating, which is exactly what we want. So actually...
And fine-tuning the game speed.
Oh.
At this point, we're no longer even worrying about the draw engines.
Yep.
That's the cool thing about doing
They're
this.
now separate.
It's all modular. Once one of the module components is done, you don't worry about that.
Yep.
You focus on the problem at hand. In this case, it's game speed that we're talking about.
Right. So, yeah.
Awesome. So a quick recap, if you want to...
Open up Notepad?
Yeah, go ahead and open up Notepad.
Notepad.
We set out in this lesson to develop the DrawEngine class.
Right.
Its job was to handle a few things, basically creating an array of sprites, and then deleting those sprites if need be, and then to be able to specify where on a screen we want to draw something, and then, of course, handling the drawing as well.
Yep.
And we had to bring in a little bit of API stuff to, facilitate, handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the drawing as well. And we had to bring in a little bit of API stuff to, facilitate handling the easy
Windows
programming.
Yeah.
Easy Windows programming. Stuff that was already there without us having to go low level or something crazy.
Yeah, we wouldn't want to do that.
Yeah, Joel
Yeah.
does. I mean, yeah, exactly. So anyways, I mean, looking at this, I think this was laid out fairly easy. If you have a hard time with it, simply go back to the very beginning and watch the big picture.
Mm-hmm.
The big picture is the important thing. And then in the end, it's just a header file and a new CPP file that we've
Yep.
created, and that's it.
Yep.
It's just that easy.
Yes, it is.
And so with that, that's going to wrap up this lesson on the DrawEngine class. Thanks a lot, everyone.